Okay, so now let's solve for Nash equilibrium. Okay, so let me first solve a very simple game. Okay, so that you get an idea about what is this best response approach, and then we'll figure out Nash equilibrium for all those games that we have we have listed above. Okay, so consider the scenario where player one's action set is, let's say, 0-1 close interval, and player two's action set is also 0-1 close interval. Okay, so there are two players. Okay, player one's action set is 0-1 close interval, player two's action set is 0-1 close interval. Let's say payoff of player one is given by this function. So u1 a1 a2 is equal to absolute value of a1 minus a2. Is that okay? And let's say player two's utility function is a1 plus a2. Okay, so it's a simple problem. Why don't you solve this now? Okay, tell me the best response function of player one. Give me br1a2. So basically you have to maximize this. Maximize with respect to a1. Okay, the utility of player one taking as given a2. Okay, so do this. This shouldn't take a lot of time. Okay, should be able to do this. Solution can depend on a2, as I've just told you that br1 is a function of a2. Okay, anybody? Okay, that's very good. Okay, there is only one catch, that when a2 is 0.5, then there are two best responses, both 0 and 1. Okay, so that is why I said that you have to write the set. Okay, so but you did it correctly. Okay, so as Jagannatha pointed out, you can have 0. Okay, 0 is the solution if a2 is greater than 0.5. Okay, 1 is a solution if a2 is less than 0.5. Okay, and then there are two solutions, 0 and 1, if a2 is equal to 0.5. Is that fine? Is everybody clear? Okay, so I mean, the way to think about this is, obviously you can plot this and do it. That's obviously one way in which you can do it. The other way is actually very simple. If you just see this, you want to maximize your distance from the other player's position. Okay, so how do you maximize your distance from the other player's position? Well, if he chooses a position to the right of 0.5, then you would want to choose 0. If he chooses a position to the left of 0.5, then you would want to choose 1. If he chooses 0.5, then you are indifferent between choosing 0 and 1. So that's kind of obvious. Okay, anyways, so can you tell me what is br2a1? Obviously, this is something that you take as given, and you can't really do anything about it. Okay, A1. Okay, so you have to choose this A2. So you're going to choose this as big as possible. So it's 1. Is that okay? Now let's plot these best responses. So I'm going to plot the graph of BR1 and graph of BR2. Okay, so in this simple problem, this is 0 to 1. Okay, this is also 0 to 1. Okay, so let's first plot this BR1 A2. Okay, so when A2 is greater than 0.5, so I'm going to put 0.5 here. Okay, when A2 is greater than 0.5, player 1 is going to choose 0. Okay, so let me use red color to plot the best response of player 1. So when A2 is greater than 0.5, A1 is 0. So it's a straight line like this. When A2 is equal to 0.5, there are two best responses, 0 and 1. So A2 is equal to 0.5, there are two best responses, 0 and 1. Is that okay? And when A2 is less than 0.5, then there is only one best response, which is 1. So I'm going to get something like this. Is that clear? So this is graph of BR1. Because remember, it's A1, A2 pairs such that A1 is the best response to A2. Okay, so all these points on this graph are A1, A2 pairs such that A1 is the best response to A2. You can check. Okay, that's exactly how we plotted it. Okay. Similarly, we can plot the graph of BR2. Okay, notice that no matter what action player 1 chooses, the best response of player 2 is always 1. Okay, so what that means is that this is a graph of BR2. Is that okay? And where is the intersection? You can see this is the intersection. Is that okay? So what is the Nash equilibrium? Nash equilibrium is A1 star A2 star is equal to, so what is player 1's action? Player 1 chooses 0. What is player 2's action? Player 2 chooses 1. Is that okay? So that's an Nash equilibrium. Notice that no player, will regret his move, okay, after playing the game this way. Because given A2 star, given 1, player 1 is choosing his best response. Okay, given that player 2 chooses 1, 0 is the best possible choice for player 1, and that's what he chooses. And given that player 1 chooses 0, well, 1 is always the best choice for player 2, so he also chooses 1. Okay, so that's an Nash equilibrium. Okay. Okay, so let's move on to slightly more interesting games. Okay, such as Kurno duopoly. Okay,